How long till we find Planet 9? When we were kids in school, we were taught that the solar system had 9 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. But after a few years, Pluto stopped appearing on the list of planets. Why? And if Pluto is no longer a planet, then what would be Planet 9? Eight planets. In previous videos, we talked in detail about how Pluto ceased to be a planet. But summarizing the story, astronomers removed Pluto from the list of planets in the solar system because the definition of planet changed. Formerly, the astronomical community never needed to have a detailed definition of a planet. After all, there were very few objects with those characteristics. However, with the arrival of new technologies and more powerful telescopes in the 21st century, we gradually began to find objects that looked like planets but were too small. The first was Ceres, a dwarf planet in the asteroid belt, and the second was Pluto. For many years, Pluto was considered the 9th planet. However, this changed on August 24, 2006, when the International Astronomical Union unanimously decided that Pluto would cease to be classified as a planet and be called a dwarf planet. This was because Pluto did not meet all the requirements to be classified as a planet. And from then on, the model they sent us to make in school had only 8 planets, not 9. But can there be a 9th planet? The 9th planet. Following the expulsion of Pluto from the select group of objects classified as planets, the idea that there could be a 9th planet came to light again, especially since such a planet had been searched for years. But if there were a 9th planet beyond the orbit of Neptune, what would it look like? How big would it be? Would it be big or small? To talk about Planet 9, you have to talk about astronomers Michael E. Brown and Konstantin Batygin of the California Institute of Technology, Caltech. They are so far the people who have more clues about what could be the 9th planet. According to research published by these two scientists on January 20th, 2016, in the Astronomical Journal, the existence of this planet can be inferred by the behavior of a group of trans-Neptunian objects. A trans-Neptunian object is any celestial body in the solar system that lies beyond the orbit of Neptune. According to Brown and Batygin's estimates, some objects such as the dwarf planet Sedna undergo various variations in their orbit that could only be explained by a body of at least 3 Earth masses in those regions of the solar system. In other words, the orbital variations of some celestial bodies suggest that there could be a massive planet with 3 times more mass than the Earth beyond the orbit of Neptune. Is this possible? And if possible, why haven't we found such a giant planet? The immensity of heaven. When we look at the night sky, we could see thousands of stars at a glance. But what do the planets look like from the Earth? Although in school we have been taught that planets do not emit their light like stars, from the Earth the planets look the same as the stars. This is because the planets reflect the sun's light. If it were not for the centuries of accumulated knowledge we inherited from our ancestors, we would not be able to differentiate the stars from the planets. Still today we know that the planets are those bright dots in the night sky that do not twinkle. As you just heard, the easiest way to differentiate a star from a planet in the night sky is to identify which of those bright dots do not twinkle. Planets are more minor than stars, but are much closer. Therefore, although they only reflect sunlight, they shine brighter than stars. So the next time you see a star that doesn't twinkle, congratulations, you just identified a planet. However, this technique only works with the planets closest to Earth, since Uranus and Neptune, although very large, are so far away that they cannot be seen with the naked eye. They are only visible with telescopes. Because of this, our ancestors had a hard time finding them. For example, in 1781, the astronomer William Herschel discovered the planet Uranus, thanks to his observations with his telescope. Still, at first, he declared that it was not a planet, but a comet. Like any astronomer and scientist skeptical of his discoveries, Herschel did not want to claim that his discovery was a planet without first corroborating it with other experts. Thus, 2 years later, the most eminent astronomers in Europe corroborated Herschel's observations, concluding that the new object discovered was a planet. Later, with mathematical calculations derived from the orbit of Uranus, astronomer Urbain Le Verrier determined the planet Neptune's position in 1846. Thanks to the most recent research, we realized that all those planets had already been recorded by humanity for a long time. In 1690, the astronomer John Flamsteed observed the planet Uranus at least 6 times and classified it as 34 Tauri, that is, a star. He died without realizing that he had discovered Uranus almost 100 years before William Herschel. Also in 1612, astronomer Galileo Galilei observed Neptune repeatedly while observing the planet Jupiter. Still, just as Flamsteed described it as a star and not a planet, Galileo discovered Neptune almost 200 years before Le Verrier, but never knew it. Even more recently, astronomer Brown, who discovered the dwarf planet Eris at the Palomar Observatory in 2005, discovered that the first image of this body was on a photographic plate made by the same telescope in 1955, more than 50 years ago. Because there are billions of stars in the universe, identifying an object as small as a planet is very difficult, mainly since planets, unlike stars, do not emit their light. That's why many scientists like Brown think it's likely we've already observed Planet 9 with our telescopes, but we haven't yet realized it's hidden from plain sight. Although there is a possibility that we already have photographs of Planet 9, it would be tough to find it among so many stars in the sky. The reason is that Planet 9, although it could be up to 5 times larger than Earth, is too far away. As we move away from the sun, the objects become darker and darker because they receive less sunlight. They are tough to observe even with the most powerful telescopes. If Planet 9 exists, it must be in a region of the solar system where sunlight barely reaches. In addition to being so far away, it would take a long time to turn the sun around, so its translational movement would be complicated to detect. If you're liking this video, let us know by leaving a like and subscribe to the channel if you haven't already. And don't forget to ring the notification bell so you don't miss any of our videos. How to see the invisible. On June 25, 2021, the National Science Foundation's National Optical Infrared Astronomy Research Laboratory, NOIRLab, announced the discovery of comet C 2014 UN 271, or Bernard and Ellie Bernstein, of which we have already made a video. Like many other objects in the solar system, this comet was detected by sequential mapping, meaning that several images of the same region of the sky were observed at different times to find something moving. This works as follows. When we take a picture of the stars, they seem to move in the same direction and speed because they are all far away. However, those celestial bodies, much closer than the stars, will move at another speed. So it will be easy to detect them if we take several photos at different times. These objects that are closer will have a more pronounced displacement concerning the background of stars. In this way, we can detect objects in our solar system. But this system has a problem, and that is that the farther away this object is, the more difficult it is to detect that apparent movement it makes concerning the background of stars. In other words, the farther away it is, the longer it will take us to realize it's there. This is likely what happens with Planet 9, although it is a vast planet, possibly a gas giant like Uranus and Neptune. According to astronomer Brown's estimates, if Planet 9 exists, it would have a highly elliptical orbit around the Sun, with a period of 10,000 and 20,000 years. On average, Planet 9 would take 15,000 years to circle the Sun. Consider that the most detailed photographs of the star in the sky were made less than 100 years ago with the world's first astronomical observatories. In 100 years, Planet 9 must not have traveled even 5% of its orbit around the Sun. In other words, since we invented the first observatories with modern telescopes to the present day, not enough time has passed to detect the apparent movement of Planet 9 concerning the background of stars. If we want to see that movement, we have to wait a few more years and then be able to say with total certainty that we will find it. What if Planet 9 doesn't exist? Although everything we have seen so far invites us to think that we are very close to finding Planet 9, some scientists believe that perhaps we are looking for a cat in an empty room. The reason for this is that the orbital variations of trans-Neptunian objects are the only proof or argument we have to defend the existence of a possible ninth planet. But many astronomers are of the opinion that there could be other ways to explain these gravitational anomalies. In this sense, our search for Planet 9 may not lead us anywhere, since it does not exist. But could we really be looking for a ghost? Vulcan planet. In 1859, the French mathematician and astronomer Urbain Le Verrier, precisely the same one who discovered the planet Neptune, proposed that between Mercury and the Sun, there was a planet that was not visible to the naked eye. This hypothetical planet was called Vulcan. Le Verrier tried to explain the variation of 43 arcseconds detected at the planet Mercury's perihelion. His study was built on Isaac Newton's law of universal gravitation. Le Verrier proposed the existence of a small planet that disturbed the orbit of Mercury, just as the orbit of Uranus is disturbed by the orbit of Neptune, as he had previously predicted. After the publication of Le Verrier's hypothesis, numerous amateur and even professional astronomers claimed to have seen the famous planet Vulcan, even appearing in the images of the solar system of the time. But curiously, no one had taken a single photograph of it. Hundreds of professionals tried to observe the mysterious planet Vulcan without success. It was believed that this planet was hard to see, since being so close to the Sun, the light dazzled the telescopes and did not allow it. But in 1915, Einstein explained the origin of Mercury's perihelion shift using his theory of general relativity. Finally, in 1919, astrophysicist Arthur Eddington made an expedition to observe the prediction of general relativity for the deviation of starlight by the Sun during the total solar eclipse of May 29, 1919, and corroborated that Einstein's hypothesis was correct. Vulcan did not produce the variations in Mercury's orbit near the Sun. They were produced as a byproduct of the Sun's gravitational pull. From then on, the idea of the planet Vulcan was discarded, and it was found that we can often claim to see things that do not exist. Some scientists think that perhaps the orbital variations we observe in trans-Neptunian bodies could be due to other things. For example, the Outer Solar System Origins Survey Project, which discovered more than 800 new trans-Neptunian objects, observed that the distribution of these bodies is indeed random. That is to say that there does not have to be a Planet 9, and in reality, what we see is due to a way of behaving of objects too far from the Sun, which we have not yet finished understanding. Planet 9 may be the modern version of the planet Vulcan, although most of the scientific community believes that there is a high probability that Planet 9 exists. We have nothing else to do but wait. What do you think? Do you think we are close to finding Planet 9? Or could it be that we are looking for something that does not exist? Let us know your opinion in the comments of this video.